anybody do the homework yesterday?
I totally forgot.
No, it's fine. Don't worry. If nobody did so, I'll leave it open for one more day. We could probably review it tomorrow at the very start of class. So one of them was a debugging exercise that you guys could do. It's just to practice basic things. I left in like 3 logical errors and like 4 like compiling errors. So today we are going to do loops. Let me add more people. So today we're gonna be studying loops in programming. So let's just wait maybe 2 or 3 more minutes. Great. So I guess we'll get started now. So welcome everybody. Welcome everybody to our 4th lesson, our 4th lecture. Julian here is going to be our teaching assistant. So if you have any questions, feel free to let him know or let everybody know in the chat. And we'll get started. So I'm going to start sharing my screen for the PowerPoint. Okay. So today we're going to start loops. So I know that for some of you guys in the if-else stuff, it was sort of interesting having the computer program execute certain cases, right? But how about if we want to do something over and over again? We can't do that really with the computer, with just if and else. So what loops do is that they allow us to do something over and over again given certain conditions. The most well, not the most basic, but one of the primary loops that people generally use is called the while loop. So the while loop is a loop that repeats a set of statements inside the loop while some condition or some Boolean is true. So this is actually like the ideal loop, a really ideal loop to use if we're looking for some conditional repeating. So if we're trying to repeat something over a condition, like when a condition is true. So here's a small little diagram you can see. The way it works is that this is sort of like when we enter the loop. When we enter the loop, and A is our condition. Well, no, not A. Yeah, A is our condition. So when A is true, we go to B. And then after we finish B, we go back to A. If A is still true, we go back to B. And then after we finish executing B, we go back to A. If A is still true, so it keeps looping around as long as A is true at the end of every B. And when A is not true anymore, we exit the loop.
Could you go back to the previous slide?
Yeah, so the previous slide states that the while loop essentially just repeats a set of statements while Boolean is true. The Boolean in this case would be A. And it is pretty much ideal for like, if you want to repeat something while given a condition. So like while, for example, that's why it's called a while loop, because it's while A is true, we keep doing this thing over and over again. We keep doing B over and over again. So you might be asking, like, are there any examples? Because like, sure, like some of you guys might be thinking, what happens if A is always true? So one example is we could say, so we have an integer called n, right? So we first make n is equal to 0. And you could have something simple like while n is less than 10, we could print n plus a space. And we could just say n equals n plus 1. So every time we increment n by 1 value. And so what happens that every time we go back to the while loop, n is incremented by 1 value. So the while loop will actually be executed 10 times in this case, because n is first 0, then 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9. But once it gets to 10, it exits the loop and it just stops. So in this case, it would print all the integers from 0 to 9. So actually, I won't go to this one just yet. But whenever we use a while loop, we have to be careful, because if we never had this incrementing, if we never had n equals n plus 1, this loop would actually go on forever, and we would just have a ton of zeros printed out. So it would just never stop printing. Like it would just be a ton of zeros, and there's no way that it would stop unless like the computer automatically stops it because it's runtime error, like running too long. So this is like where you have to be careful. Whenever you use a while loop, you have to make sure that the condition can be false at some point in the program, right? Or else it'll just keep going on forever and it will not stop. So that is one thing you have to keep in mind. So what is a really nice, I guess, application of the while loop? So you guys remember yesterday's, I guess, example using like the lottery when we had like if and else to like talk about like sorting and to compare numbers. So this is another application to the lottery. So first we made a scanner here called input, so we could read the user input. The second thing is that we prompt the user, so we had enter a number. We created an X which carried the value of that number. After we generate a random number between 0 and 10. This case I put 10 because I wanted to show you guys what it would output, and we'd store that in Lotto. Now we create a loop, which is while X is not equal to Lotto, we print your guess is wrong, re-enter a number. So pretty much in this case, we are pretty much allowing the user to keep guessing the Lotto number, like the winning number. We allow the user to keep guessing the winning number over and over again, because we're saying while the guess is not equal to the winning number, we are printing out your guess is wrong, re-enter number. And when we have X equals input.next int, we are saying, we are telling the scanner, we are pretty much, not telling the scanner, but we are like using the scanner to prompt the user again. And we are getting a new input here. So we have X equals input.next int, and yeah. So pretty much when the user does guess the right winning number, X is not equal to Lotto will be false because X is equal to Lotto. So then when the user does guess the correct integer or the correct winning number, it exits the loop and it prints, congrats, you got the right number. So let's look at my bad luck, because when I ran this program the first time, I had really bad luck. I actually had to guess around 8 times. So enter number, I put 5, said your guess is wrong, re-enter number. It was 7, 9, 4, 3, 2, 1, and I finally got the right number at 0. So is this all clear? Okay, so
So-
I'm going.
Sorry, you did times 10 because you want the limit to be 1 through 9, right?
Yeah, no, 0 through 9.
0 through 9, sorry, yeah. All right, sorry. I just got in, sorry about
It's because I did not want to try to guess at 1,000 number lottery. That would be a pain. So you see, my luck was already really bad, even at 10 number lottery. So let's continue. So there's a second type of loop that we should all learn called a for loop. And what a for loop does, it is a loop that works under a counter. So you guys all know what sort of like a counter is? Well, I guess we'll look at it in the next slide. So, for example, what we do is that we say for, and so this looks a little bit complex, but I will explain it. So we create an integer called something. It's normally called I. Most people use integer called I. So we say for int I equals 0. So we define a variable here. We defined I in this case, semicolon. We say I is less than some number, so 10, and we put another semicolon, and we have to give it like an increment. So in this case, I plus plus means that we add 1 to I every single time we run the program. So I plus plus means that every time everything in the loop gets run, we add 1. So the way it works is first I is equal to 0. So we start running the loop. It first checks if this is true. So we start with int I equals 0, and is I less than 10 right now? Just asking.
Yep.
I is less than 10. So if this is true, the second statement, I is less than 10, if that is true, then we run what's inside the loop. So we print hello. Now at the end of the loop, we go to the third statement and it says I plus plus, which means we increment I by 1 every time. So we get to the end of the loop, we go back inside, and now I is equal to 1 because we add 1. Now it's the second statement still true.
Mm-hmm.
Yeah, so when the second statement is still true, we run what's inside the loop one more time. And when we exit, we go back and we pretty much say I plus plus. So we add 1 to I, and now I is 2. As long as I is less than 10, we keep running the loop. But once I is equal to 10, we exit the loop. We don't repeat it anymore. So when I gets to 10, we pretty much just say, nope, we don't run this code, and we move on. So what this does is pretty much just print hello 10 times. That's what it just does. So we could also do this a little bit better. Just wait 1 second. Sorry. No, sorry, there is something going on outside. Yeah. So in this case, we printed hello 10 times. So we define a variable. It doesn't have to be I, it could be J, and it doesn't have to start from 0. It could start from like 1 or something. And yeah, the cool thing about this though is that we could use I inside the program. So if we wanted to add, for example, all the integers from like 0 to 10, we could do this. We created a variable called sum outside the loop. So we have int sum equals 0. And for int I equals 0, I is less than 11 and I plus plus, we say sum gets sum plus 1. So pretty much every time we go in this loop, we add, no, not 1, my bad. Sum gets sum plus I. So every time we go in this loop, we add I to sum. So in this case, the first time we go through it, I is equal to 0. So sum is still equal to 0. But then when we finish, we say I plus plus. So now when we go back in the beginning of the loop, we have I equals 1. Afterwards, we get sum equals sum plus 1. So now sum is equal to 1. And when we exit the loop now and go back to the beginning, I plus plus, we have I equals 2. As long as I is still less than 11, we keep going through it. And because pretty much we execute this for I equals 0 to 10, we add all the integers from 0 to 10, which is equal to 55, as you see. So at the end, we pretty much, just printed the sum. So this is a little program I coded for to calculate the C value of given data set. I coded a really long time ago, but let me stop sharing and I will click the link and I'll show you guys about it. Am I going a little bit too fast or can everybody catch up?
No, I'm following this.
Okay. If you have any questions, just tell me. Okay, so this is the program that I coded. It was like, I think sometime in January. It was for a small project. I was trying to calculate t-values of something, but I couldn't really find a program online to do that, so I decided to code my own. So let's just, it's a little bit advanced. You don't have to, oh, what just happened here? Okay, I don't think I could change it actually. Okay, so it's a little bit advanced, so you don't have to understand everything in it, but I just wanted to sort of break it down a little bit so that you guys know how like people generally could use for loops in their thing. So what we did was we first did scanner s equals new scanner. So I created a new scanner here called s, and we first prompted the user. So how many data samples you have? So now we create an integer called n, and we pretty much read the user input. So now n is equal to the amount of data samples that the user has and the amount of data samples they want to run the test under. They want to calculate the t-value for. So now we use a for loop. We say int I is equal to 0, I is less than n, and I plus plus. So because we said I is less than n, pretty much I is going to be, we're going to be asking them the amount of data samples they have. So for example, because like we're running this loop n times, right? And n is the amount of data samples they have. So we are running it for the perfect amount of data samples they have. So every time this loop happens, we prompt them. We ask them data samples plus I plus 1. So I plus 1 is a data sample number because we started at I equals 0. So pretty much I plus 1 is a data sample number. So let me run it just real quick and let you guys see. So let's say it first asks if it's going to run in time. Let's just wait. I'm not sure how slow REPL is right now. All right, so how many data samples do we have? How many do you guys want to put?
20.
20? That's a lot. I don't want to input
5.
All right, 5.
5.
Okay, so the way it works, t-test, it has, you have 2 data sets. So every time we do something, we're going to have to input 2 numbers. So data sample is 1. What numbers you guys want?
7.
7 and
6.
6. So this is going to be data samples 1 from set 1 and 2. So this is data sample 1 from set 1, data sample 1 from set 2. When we press enter, notice how it asks now data samples 2. This is because in the for loop, in the system.out.print, I had the I plus 1 in there. So it will always, so when I always increments, the data sample number also always increments. So this is also a nice little thing you guys could do when you guys prompt users within a for loop. So pretty much, after we collect all the data, I stored it in an array list. You do not have to know what that is. I mean, we're not going to go over arrays. So after I stored an array list, this is pretty much all the calculation. Everything else is calculation. So at the end, we just say the t-value is equal to this, and that's done. So if we just finish, I'll just show you, plug in random numbers, 1 and maybe 1, 8. The t-value is equal to 0.298 something. So that was a program that I made quite a while ago for t-values. Let me stop sharing for a second. But the reason why I showed you that was because I just wanted you guys to see how you could prompt users within a for loop. You guys all get this sort of idea? If we're collecting like a certain amount of samples or a certain amount of numbers from a user, what we could do is we could do a for loop, and if we want to prompt them really well, make them know which data sample they are, or which sample or which data something they are inputting, like which number, we just use the I, right? Because you can use I within the program. So that's a really nice thing inside the for loop. So let's go in REPL because I know none of us have, well, a lot of us here have not ever touched hands on a for loop. So let's all go on REPL together. Okay, so let me start sharing screen. So can everybody see my screen here?
Yeah.
Okay, so we're on REPL now. Okay, so let's create a random program, I guess. So let's first start with while loop. So int n equals 0, and let's print 10 hellos. So how would we print 10 hellos? Anybody want to give it a try?
For space.
Oh, using while loop.
Huh?
Using a while loop.
A while loop?
Yeah.
Oh, did you go over that in the beginning?
Yeah, we went over that.
Oh, okay. I wasn't here for like the first 5 minutes.
Oh, okay. Anybody want to give it a try?
Is it while parentheses n is less than 10?
Yeah, right. So we have while is less than 10. And what do we have inside the braces?
System dot out dot print. Is it parentheses n plus? Is it and then the what is it?
What's inside the
Like
print?
space.
Space. We're trying to print 10 hellos, right?
N plus quotations.
Not n plus. We're trying to print 10 just regular hellos, right?
Oh, right.
All right. What's next? Or is that it?
You have to put like n equals n plus 1.
Right? You have to increment n, or else we get an infinite for loop, right? So let's print it, and look, we have 10 hellos. Let's see what I want to see what happens actually if we do. I think it'll just go on forever without printing anything actually. But let's see. If we leave it out, oh no, it just keeps going. You see? You see all those hellos? If we don't have the increment, it just keeps on going, just keeps printing hello. So yeah, it's really important that you guys have this increment, or else you don't want your program to glitch out, and this is what happens. Okay, so now let's do something else, I guess. Let's make a for loop. So who wants to print 10 hellos? Who wants to tell me how to print 10 hellos using for loop? Anybody?
Do we have to put like int?
Yeah, we have to first declare our counter, right? So actually, you're allowed to use n. I'm pretty sure you don't have to declare it, but in this case, we do not have an I, so we could declare a counter. Int I equals 0.
Then I is like less than n.
Less than what?
N. Oh yeah. Wait. Yeah. N.
Wait, why n? N is equal to 0 in this case, so it would not execute.
Good point.
We want 10, right? So what number should we put?
Right.
10.
Because there are 10 numbers between 0 and 9. And then what do we increment by?
I plus plus.
I plus. So what do we have inside?
System out print data samples.
And we print hello, right? Because we're printing 10 hellos. Well, we have to have a line, so it skips. Okay, so now let's run it. Notice how in this case, we do not have to increment I because the program automatically increments I. If we have an I plus plus in here, it would actually increment I twice. So in this case, we would only have 5 hellos, right? So, oh, by the way, I plus plus is shorthand for I equals I plus 6. So I plus plus is the shorthand for that.
Would we ever be allowed to put like n plus plus?
Yeah, I could write n plus plus as well. So plus plus is shorthand for just something gets something plus 1.
Mm-hmm.
So like we could also write I equals I plus 1. It still works. You see? So now I'm gonna give you guys a small exercise for loops. Let me screen share this PowerPoint. So code a program that allows users to input the amount of items they bought and the cost of each item. Then print the total cost of the list. So this is pretty much like a grocery list program. you first ask the user how many items did you buy, and then afterwards you use a loop in order to allow them to input the cost of each item, and afterwards at the very end print the total cost of the list. So I guess I'll first start you guys off so that you guys know how to start this off. Okay, so let me start this off with you guys. So the first thing to do, so the first thing we don't know is how many items they bought, right? So how do we get the amount of items they bought?
You ask the user for you use a scanner.
We get the first import Java.userWall scanner. And then, so what do we do first? We have to create the scanner, right? My bad. What's now the second step? Any ideas?
So what's the challenge again? Sorry, if you could
Okay,
say it
so
again.
the challenge is to create a program where we ask the user how many sort of grocery items you bought or items you bought, and afterwards we let the user input the amount, like the cost of every item, and then we print the total cost.
All right. I think
So we first create a scanner. What's your second step? What's the first value we have to get from the user?
n.
And right, the amount of numbers, the amount of
Right.
items they have, right?
Right.
So first we have to prompt them system.out.print items, right?
Right.
Now what's next?
Do you use the for loop and you replace like after the comparison symbol, I forgot the less than symbol, you put an n,
Okay.
which
But first we don't have an n, so we have to define n, right? It's n,
oh right, we have to define it.
that's input.next6. Right?
And then you put the syntax for, right?
Yeah, so now we have a for loop. And what do we have inside? I equals 0. Less than, what is I going to be less than?
N
N, right? Why n?
because n is the boundary, the not the boundary but the
Greatest. The greatest, the greatest amount of times you want to run the, well, actually the
you're right.
exact amount of times you want to run the for loop. And we increment it by 1. So we say I plus plus. And then I'll leave the inside for you guys to do alone. So, oh, actually, you forgot one thing. We want to get the sum, right? So I'll give you one hint. Let's create a value called sum on the outside to make it equal to 0. I'll give you guys around 5 minutes to try to finish this, or 7 minutes to finish this on your own. And yeah, I'll just leave you guys alone with this. So go on REPL. You could copy I'm gonna actually copy and paste this code in the chat. So I just copy and paste in the chat. You could go ahead and copy and paste it into your REPL. I'm not sure if it's gonna work too well if you copy and paste it directly from the chat. But yeah. So just try to finish on your own. Is everybody getting finished? Anybody?
Oh,
Who needs time?
I'm still working on it.
Still working on it? Okay. If you need more time, just tell me. And yeah. I will start in around 2 minutes. So just letting you guys know. Yeah, as Julian just posted, if you have any questions or if you need help on your program, you can feel free to unmute yourself and ask. So I'm going to start actually right now. For those of you guys who are still finishing up, you can still finish up while I present. So, okay, I hope you can see my screen, right? So the first thing we did was we had to get the amount of items the user has, right? So we stored that in a variable called n. And the second thing we did was we created an empty sum. So right now, this variable sum has nothing. So the first thing to do is, what is the first thing to do actually? Can somebody tell me? Feel free to unmute yourself and just say if you have an answer.
I wasn't sure what to put, but I think I put like system out print.
Yeah. So let's do prints.
I put enter the price for object and then like number. I made it so. For
Actually, we could
number,
change this I to 1, and we could change this n to n plus 1, right? So that because this still executes exactly n times this formula. But the only thing is we could have a better I, right? So enter the Oregon thing. What do you print afterwards?
what I put was I put plus open parentheses I plus 1 close parentheses.
Yeah, that would work if I is 0, but we just changed it to I equals 1. So we could just do I, right? Because if I is 1, we could just start with I. So that's the advantage of changing what's inside the for loop. We could change. We don't always get to start from 0. We could start from 1 if we want. And what we're doing though is we're doing n plus 1. So what's next?
After that, I was just kind of stumped.
So now we could define a variable, random variable called like int item, right? Int cost. That's input dot next int, right?
Why not a double? And because what if there's like pennies or
My bad. Yeah, you're right. Double's better in this case. So we have a double in this case called cost. And every time we run the for loop, we will ask the user to input the cost. So we say the user input in this double called cost. Now, if you notice, we define the double cost within the for loop. So every time it exits the for loop, it'll be as if it never existed. Just saying. So just know that.
I have a question about it. In input.nextInt, does that matter whether it's a double or not? When you have
Oh, no, it is my bad. It's because I said ints first, so that's why I typed int.
Okay, I was just wondering.
If it's double, it has to be double. Remember that. Yeah. You caught that one. Thanks. So what do we do after we created this cost variable? You remember this cost variable changes every time we run the for loop. So it's actually never saved because every time we finish running the for loop, it disappears because whenever we go back in, it always changes. So what did you know?
I was trying to figure out a way to make it so like I can name it differently each time. I was trying to create like a new name for it each time, but I couldn't figure out, like I tried putting parentheses I plus cost. I put cost in parentheses and I did plus I, but I was trying to see if there's some way I can like add it together, but it just kept giving me errors.
Yeah, you can't do that. The best way here, remember I told you we have this double called sum. So
Right.
we could use, actually, we could say sum gets sum plus cost. So we don't actually store costs. We erase cost every time, but we actually just add cost to sum. So sum is now getting, when we exit the for loop, it's going to be the same exact thing as adding all of the costs together, right? So that's why I gave you that hint. We create a double called sum in the beginning, and then we do sum equals sum plus cost. Right?
Right.
Okay. And now what do we do? We use system.out.print on what we have in the middle.
The total price is
And sum. And let's run this program and see what happens. All right, so how many items do we buy?
7.
7, okay. Oh wait, actually we should make it a little bit better. Let's have a colon here. So user input looks a little bit better. Let's have, oh wait, no, my bad. Not a colon there. A colon after the I. So it just looks prettier, right? It's nice to have your programs look pretty. So let's just wait. Okay, so 7. Now, what is the price for item 1?
You could go in ascending order, maybe, or like
Any order.
or 9.
9. Okay, so $9. Let's say item 2 is $3.99, and I guess $9.99 because whatever, and maybe like $10.49, or maybe like $6.49, or $9.99.
Or 20.
It's $20. So our total cost will be $1,000, $1,058.96. So yeah, this is how this. So for loops are, as you see, are actually very, very useful, right? Okay. So now, as we finish this, I want you guys to modify this so that instead of making it sort of like a grocery list, we ask, let's say we ask the user to input an amount of numbers, but instead print the average. So how would we be able to modify this to print the average cost? So instead of the total price, you say the average price.
Are you asking us to do it by ourselves, or do you want us to speak out?
You can speak up, it's fine. These are just like just a tiny change.
So for sum plus cost, would you put that in between parentheses and then put that over 2?
No, why would we
Wait.
put that over 2?
Hold on. I'm trying
Over
to
the
think about
number
this.
that you added by.
So what is the average? So let me annotate this. So what is the average? Average. Wait, what's the symbol for average? Is it mu? I think it's something like mu. Equals the sum of everything. The sum of an divided by the total amount, right?
I think X bar is like the average.
Oh, X bar. Okay, yeah. I think mu might be standard deviation. I'm not sure. I'm not sure. I totally forgot.
Oh, yeah.
Mu is population mean,
Okay.
like in stats.
So I think it might be bar, right? Let's just say a bar. So the average of all a's is equal to the sum of all the a's divided by n. So this is just really small fix, right? What should we do?
Sum divided by n.
Yeah, right, because we already have the sum. This for loop got the sum of all the costs, right? Because every time we went through this for loop, we said sum equals sum plus cost. So the for loop already gives us the sum. All we have to do is just divide by n. So in this case, it would give us the average price. That's I'm gonna do maybe just 5 items because I'm lazy. Let's say 5, $1.99, $2.99, $3.99, $4.99, and $5.99. If this is correct, it should give us $3.99. Oh yeah, the average price is $3.99. As you see, actually Java here is having a little error. I think I forgot what type of error this is called, but it's because I don't know, when computers do, it's like a floating point error, I think, because like it's not exactly 0, but it's pretty much 0. It's just having that little error, like a little clinging thing, like 0.00001. It's called a floating point error, I think. But yeah, you see, it's pretty much a $3.99, right? Okay, so that's how you get the average. So let me give you guys another activity. Slideshow. Okay. So actually, no, my bad. I wanted to first talk about this because I'm going to give you guys a really hard program next. A really hard program. I mean, not the next one, but the one after next. So I just want to talk about how we went through this. So the first thing we needed to do to get through this is that we needed to know the amounts of items that the user had, right? So we first prompt the user to enter the amount of items she had, and we stored that number inside a integer called n. Afterward, we needed to get all the costs of those items. So we just created a for loop and had we couldn't just store all those variables for cost, but instead what we did do was we created a double called sum in the very outside of the for loop, before the for loop, and then we just had sum equals sum plus cost every time. Afterwards, we needed to add them all together, so we did that sum. So we did these two under the for loop, and then we printed the sum. The next thing I'll do, it is going to be much easier than this one. I want you guys to code a program to take the factorial of any number. So a factorial, do you all know what a factorial is?
I don't remember hearing that before.
So factorial is something denoted as n exclamation mark or n factorial. It is equal to n times n minus 1 times n minus 2 times all the way to 2 times 1. Somebody's microphone is going off. I was wondering if, okay, actually never mind. Wait, is my video stable? Just wondering.
Yes.
Yeah.
I'm just trying to make sure. Afterwards, so for example, 6 factorial would equal to 6 times 5 times 4 times 3 times 2 times 1, which is equal to 720. 7 factorial is 7 times 6 times 5 times 4 all the way to 1, which is 5040. So yeah, so I want you guys to code a small program that can ask the user for some integer n, and you print what is n factorial. So I'll give you guys around 5 minutes to do this. So the first thing I want to ask you guys is, I want you guys to follow our steps before. What do we need first? So in this case, we need what? We need n, right? That is what we need. We need to know what n is. And the second thing, what do we have to do? Instead of adding them all together, we have to multiply them all together. So that is just some hints I gave you. So yeah. So once it gets to 57, I will start presenting this.
If we made an account on REPL and we want to save what we already typed, but we want to start a new one, what do we do?
What you do is you press on the top right-hand corner. There is something called new REPL, and you press new REPL.
Oh, but it saves everything we already did?
Yeah, it saves everything else.
Got it. Thank you.
If you need any help, Julie and I are here, so feel free to ask us.
So for a factorial, you multiply all whole numbers from the chosen number down to 1, but if you start a negative,
If you start negative, I don't think it's defined at least. So for example, if it's a decimal, it's actually much more complicated. You have to use calculus to in order to solve for factorial. So generally, just assume it's an integer.
it's an integer, but an integer can also be negative, right? So
Positive integer. I don't think at least I don't think negative integers can have factorials, unless you extend the definition using calculus. So.
Right, sorry. All right, just wanted to make sure.
Yeah,
It's a pain to do. It's a big pain to do factorials for decimals. Yeah.
You have to use, I think, the gamma function.
What grade level is like not grade level class like
Calculus.
class calculus? Oh, okay.
factorials are in combinatorics. I think factorials are made for combinatorics actually. They're useful for counting ordering. So for example, if I have 4 books on a bookshelf and I want to count how many ways how many orderings of the books I could have, it's equal to 4 factorial, which is equal to 24.
Yeah, it's used a lot in statistics.
So for example, I believe like 0.5 factorial is equal to square root of pi divided by 2, I think. So like it's really complex to calculate those.
Garcia would be proud.
So I'm going to start. It is 1:57. I just wanted to make sure we have time for the lab section. So let me start sharing with Google Chrome. Can everybody see my screen? All right, so what is the first thing we have to have? We have to ask the user, what is the number, I guess, I don't think factorialize is like a verb or anything. So what number? So now n is going to be our factorial, right? So what do we do after this? So do you remember back then we had to create a variable called sum? So what do you think we could create now?
Product?
Yeah, right. Or we call it factorial actually, because in this case we're making a factorial. So what should we make it equal to?
1.
1, right? We don't make it equal to 0 because 0 times anything is 0. So the reason why you made sum equal to 0 is because 0 plus anything is equal to that thing. So what loop should we use? Oh wait, what? What just happened? Strange. No, REPL, why are you doing this to me? I think REPL is having, okay, never mind. So what loop should we use?
While.
While, right? We could use for loop as well, but while loop is generally the easier one. It's really nice syntax. Because like we don't have to have like int I equals something, and right? So we could do just say while. Now what can we do? So we start with n, right? And you want to multiply all the numbers from n until 1. So for example,
While n is greater than 0.
yeah, right, while n is greater than 0. Because we want to do, oh, sorry, let me see if I can type, okay. While n is greater than 0, because we want to multiply all the numbers all the way from n all the way until 1, right? So 1 is going to be the last one we do because n is going to be greater than 0. So yeah.
Since it's a factorial, I mean, since it goes down to 1, does that mean it can't be less than 1?
You could have like 0.5 factorial, but once again, I said you have to use like calculus, so we can ignore that. So what can we do in this case? What do we do in this loop?
Make f equal to f times n and n equal to n minus 1.
Yeah. So factorial equals factorial
Sorry.
fine, times n. Thank you for telling. And afterwards, if we don't, because remember, if we don't increment n at all, then n is going to be always equal to, n is always going to be greater than 0, right? So the loop's always going to keep running, keep running, keep running, keep running. So after what we can do is we say n equals n minus 1. So the first time we answer n is equal to n, so factorial is now equal to 1 times n, which is n. And now n is equal to n minus 1. The second time we answer the loop, n is now equal to n minus 1. So factorial gets n times n minus 1, which is, and n is now n minus 2. The third time we answer the loop, factorial is equal to n times n minus 1 times n minus 2. And now n is equal to n minus 3. And you get it. It keeps going, keeps going, keeps going, and keeps going down until we get to 1. Once it gets to 0, we ignore the loop because the Boolean is now not true anymore. So we exit the loop. And now we have to print it, right? We say n plus factorial sign is equal to, we say plus factorial. So let's run. So what number do we want to take the factorial of? Remember, factorials grow really quickly, super quickly. So what number do you want to take the factorial of? Don't make it a big number.
4,
5.
3.
3? Say 3. So 0, wait, what? 0 factorial? Oh, my bad. It's because when we exit loop, n is equal to 0. So we're going to have to change that. It says 0 factorial is equal to 6. So maybe we could do another thing. We could save n as well. So we could say int c gets n, or maybe n2 gets n. So this way we save n within another variable. This variable will never get touched. So this case we could have print n2. So if you look at this, we press 3. If this runs, it's 3. And so 3 factorial is equal to 6. You guys get what we did here, right? Because n always gets touched, we cannot use n here anymore when we print the statement. Instead, we could create a new variable, store n inside that new variable, the original n, and just never touch this new variable, right? If we never touch this new variable, at the end of the while loop, it is still equal to n. So that's what we could do. So here, let's continue. What number do you guys take the factorial? Let's say 4. 4 factorial is equal to 24. Now, let's be careful. Even though we have to be careful, let's see what happens if we get a big number, right? What number do you guys want to take the factorial of?
175.
175? That's a very big number. Okay. So 175 factorial is equal to 0. You guys know what happened here?
It's just way too big.
Not way too big, but remember, when we have sort of overflow, it goes all the way towards the beginning again, and then, right? So eventually, we might just keep going, and we'll, let's say, 10 factorial, I think, is approximately 1 million. So, or 3 million. I meant 3 million.
What is?
10 factorial, I think. So 14 factorial should be negative, I think. It should go, so you see 4, oh wait, no? Oh yeah. Wait. Did it overflow too much? All right, let me see. 15. Yeah, you see, it like barely increases. That's because when it overflows and in a multiplication, when we get to the end, it goes all the way back to the beginning, and it keeps going until, I guess, until it stops, right? You guys remember what overflow was in the beginning, the first day of class?
Yeah.
Yeah. So if we do very large numbers, int is no longer a trustworthy thing to store data in. So there's another data type called long. It's pretty much, it stores an integer, but it stores in a very much larger range, like a larger range. So let's see how accurate long is. And let's see. So this one was like 2 point something times 10 to the something, right? So let's see what 15 does if it's long. So you see, it's a much larger number. much more different number when we put in long, because long is much more accurate, because long could store much more digits. So that is, I guess, the what is better about having a long data set. If for some reason, I guess, we get a wrong input, so let's say if we made it a double, right? Let's say we make this a double instead, or maybe a long, my bad, sorry. Let's say if the user put in like 0.5, or not 0.5, but like -3. How can we prevent them from putting negative inputs? So what we could do is, you see this when we first define n and we give n input.nextInts, we could use right after we define n, we could have a little while loop. So while n is greater than or equal to 0. So while n is non-negative, or if you want, we could use the Morgan's law. We say while n is less than 0 and not, we can have not here. So while n is not less than 0, so it negates this. So while n is not negative, so that's what this means, while n is not negative, we can say, oh wait, my bad. I meant to say, while n is not positive. Sorry. So while n is not positive, you see here, while n is not greater than or equal to 0, we could do is we could redefine n. We ask the user to do another input. So we could use system.out.print, and we could say error, your value and then after we could prompt that again, right? We could copy and paste this, and we could just say sim.out.print. What do you want to take the factorial of? And instead of redefining long here, we could just say n equals and put the next thing. Do you guys guess? Do you guys understand what we're doing here? So we're saying after we get the user to input n, we say while n is not positive or not non-negative, because this is not positive, equals 0. So while n is not non-negative, we run this. We say error, your value is not negative, please try again. And we then prompt them again, what number do you want to take the factorial of? And we say n equals input.nextInt. So we keep re-asking them to input n until they give us a positive n, right? So if you want to take the factorial of, let's say -4. Error, your value was negative. Please try again. What do you want to take the factorial of? Let's say -2. It keeps asking us. That's error. Your value is negative because n is still negative. So we keep going through this while because n is still negative. So until we give like a valid number like 0, 0 factorial is equal to 1. Yeah. Actually, this is true, by the way. 0 factorial is equal to 1. So if you guys are wondering, by definition. But yeah, this is how we could make them. It's sort of, I guess, a simple way of caching like certain cases that your program was not meant to have. Because our program was not meant to run negative factorials. So in this case, it's sort of like an easy way to do it. We just have a while loop. So while n is negative, then we ask them to re-input the numbers. So do you guys get this one?
Yeah, I have a question.
Yeah.
On my right side, it's showing me that I have 3 different errors, and it's showing me like where the errors might be, and it's saying that they cannot find the symbol. But it's saying like for example, when we wrote factorial equals factorial times n,
Yeah.
it's just saying like the times symbol, the shift 8, it's saying like it doesn't understand what I wrote.
Really?
Yeah, and then the same for the S on scanner at the beginning, like Edna.
True. You try emailing me your code. I'll take a look at it later.
Sure.
Okay, thanks. So the next thing, the reason why I want to go through this is because our labs are going to be really hard today. They're going to be really tough. It's a large step from what we did. Do you guys know what a TI-83 calculator is, or 84?
Yes.
So you know when you want them to find the roots, right? So do you all know what
Right.
roots are?
A what?
What roots of a polynomial are, or roots of a function? So we're probably gonna have to do a little bit of math here because I know we come from all different levels. Some of you guys have just not taken Algebra 1 yet. Some of you guys have probably taken like calculus already. So let's say we have a function. Do you guys all know how to graph a function? If you don't know how to graph a function, please let us know in the chat. And then, because this is gonna be really hard if you do not know how to graph a function. So please let us know. So let's say we have a graph of function like f of x, and it's just like that or something, right? The root of a function is a value of x such that the function is equal to 0. So that is a root, for example. So have you guys ever used a TI-83 calculator?
I don't think so.
No. So the way TI-83 calculator works is you have to input two values. You have to input a value of x such that the function is still positive, and you have to input a value of x such as the function is still negative in that area, right? Right? So this is, in this case, we can input these two values of x, x1, x2. And what's going to happen is that it'll run some algorithm and it will return to us very accurate value for the root, right? So have you guys really, I guess, thought of how this works? So wait, I'm just wondering, is everybody with me or is anybody lost? Because this is going to be, it's going to be really rough if you do not understand what I'm talking about right now.
I mean, I'm with you, but I've been through high school. So.
Yeah. So like, don't be shy. Message me or Julian. Well, no, don't message me because I can't see your messages right now. But message Julian if, or everyone if you have any questions. Don't be shy because I don't want you to sit through this next hour like painfully. So let's say we have, for example, a function like this. We could, one x we could input is this one because it's positive, and another x value input is this one because the function is negative for that x. And the TI will return this value of x. So I'll teach you guys sort of the algorithm. Well, I'm not sure if the TI calculator still uses it, but I'll teach you guys the algorithm. So there's something called the intermediate value theorem. I know this looks a little bit complicated, but it's not really. So if we have two values, f of a and f of b, right? So f of a is here, f of b equals here. Every value in between them, the function has to go through it if like the function is continuous, which makes sense, right? Because how can we get from f of a to f of b if the function is continuous and we skip over some value, right? So for example, this red line, the function, no matter what, if it's continuous, it will always have to pass through this red line because it is in between them, right? I mean, the function can't just, if it's continuous, just like sort of teleport and just break off, right? So you guys sort of get this idea? If you have any questions, just tell me. So let's continue now. So what we're going to do is we're going to learn about the bisection method. The bisection method is if you give me two values such that one value is negative, one value is positive for f, we're always going to have a 0 in between, right? Because 0 is in between a negative number and a positive number. So no matter what, we're going to always have to have a 0 in between a and b. So what we could do is we first cut this section in half. So c is the midpoint between a and b, and we cut in half. And now we have f of c, right? If f of c is negative, then f of c will become our new a, right? So c replaces a now, and we now only have this section. If f of c is positive, then c now replaces our b. And then we repeat it all over again. So in this case, c is negative, so c replaces our a, and we start over again. So let me get let me annotate the screen. Pen. So now c is our new a, so we get rid of this part of the graph, no more. And after we repeat the whole thing over again, we cut the graph in half. and make this equal to C prime, right? In this case, C is positive. So now C is our new B. So we cut off this section of the graph and we start it all over again. We cut the graph in half, right? We cut it in half. And now this value is a negative or positive. This graph, this part is negative. So C replaces this part. So we get rid of this graph. And we keep doing it until we get a small section that is like 0.0000001 units long. And pretty much we're like super close to 0, right? Because after those digits, it doesn't really matter. So we get super close to the root. So at one point, we'll just get so close that we'll just say this is a root. So that's how this method works. Does everybody understand this? Do I have any questions from anybody? Feel free to ask.
So you just kind of go from like 2 equidistant spots from the root and then just cut it in half and in half.
Yeah, so if you give me 2 spots, what I'll do is I'll cut in half. And if it's still not the root, then I replace either A or B with that value. And we have a new segment to work with, and we just repeat the process. We cut it in half. And if it's still not the root, then we repeat it. And we cut it in half again, and we cut in half again, and we keep cutting in half until we get to some like 0.0000 something away from the root, right? And in that case, we'll just stop. And we're just so accurate that we'll just say, okay, this is what the root's equal to now. So this project is, I want you guys to sort, oh wait, my bad. I want you guys, well, we're gonna code this together because it's a really hard thing to code. So if we're given a function, f, I want you guys to code with me a way we could sort of find the roots of the f. Okay, so let me stop annotating. I'll stop sharing screen right now and I will share rep with you. So is everybody with me or? So we're pretty much coding a TI-83 calculator program in this section. So so can everybody see the screen? So you don't have to worry what this is. In this, we just create a method called f. So whenever we say f of x, so for example, I just implemented this in order to have f. So if we just write f of 2, it'll print f of 2. So this is something I added in the program to have. So in this case, xf, oh wait, what happened here? Java not a statement. Public static double. Return x times x. Sorry, wait, let me see what's wrong with this. Okay, so if x is equal to, let's say, x times x times x, and we print f of 2, it'll print 8, right? So this is just something I implemented in the program. So minus 3 times x plus 1. So we could just have f of x in here. So what's the first thing we have to do? We have to prompt the user, right? So actually, we have to make our scanner. So we haven't made our scanner yet. So we have import java.util.scanner, right? And then we have to make our scanner. So scanner input equals new scanner system.in, right? And what's the next thing we have to do? We have to find we have to ask the user for 2 endpoints, right? So how can we do that? I guess we could just do system.out.print, enter the lower bound, and int a equals input.nextInt. Or no, we can make double actually. A gets input.next double, right? And then we could repeat this process and have the upper bound. So let's copy and paste this. Enter the upper bound b equals input.next double, right? So what is the one thing that will give us an error?
Oh, like if it was like what would give us an error based on like what they enter?
Yeah.
I mean, if they enter a non-real number.
Well, not a real number, but
If
if
B
they
is
enter,
less than A,
not if b is less than a, but if, well, would that give us an error? I'm not sure. It might. Yeah, that would give us an error actually. But another thing that would give us an error if f of a and f of b are both positive or both negative, right?
Why is that?
Because remember the
Oh,
bisection
it's
method?
on the y-axis.
Yeah, because if f of a is positive and f of b is positive, we don't know if there's a zero in between, right? The intermediate value theorem only works if we have one is negative and one is positive. So
Right.
we have to make sure that while, right? We're going to use a while loop, while f of a is greater than 0 and f of b is greater than 0, or f of a, let's do another parentheses here, sorry, f of a is greater than, no, less than 0, or, no, and f of b is less than 0. What do we have? We have to ask them for two new inputs, right? So we would have system.out.print. Let's have a new system.out.print. Error, no sign change, right? That's what the TI tells you. Error, no sign change. And afterwards, we start with enter the lower bound, enter the upper bound, right? So if they're here, what we were saying is that if f of a is greater than 0 and f of b is greater than 0, or f of a is less than 0 and f of b is less than 0, we have parentheses around it, so it's like two things. Then we do this. So we're saying essentially saying if both f of a and f of b have the same sign, then we keep asking them for new values, right? We keep asking them over and over again, please input a new lower bound, new upper bound over and over again, right? Am I losing anybody, or
That made sense.
everybody
Yeah, that
good?
makes sense.
Okay, so let's continue. So now we have the f of b and f of a, right? So now what, I think it's Nicole, right? Is that what you said, Nicole?
yeah.
Okay, she said that if f of b is less than if b is less than a, we also have an error, right? So we have to make sure that b is also greater than a. So if b is less than a, we could swap them, right? So if b is less than a, we swap them. So we say, we create a new integer called temp, which is equal to a. And now we have a is equal to b, and now b is equal to temp. Remember this from yesterday, guys? Does everybody remember this? This is how we swap two numbers. We created a temporary number, or I should say double actually, because a and b are doubles. So we created my bad, sorry. We have to get rid of this double. We're not redefining them. So double temp is equal to a. We store the value of a inside a temporary variable, and now we have a is equal to b, and now b is equal to a because the temporary variable saved a, right? So in this case, if b is less than a, we swap them. Now what do we do?
So I'm gonna keep it as short as possible, okay? Because the other class needs to log on as well. Listening skills. Can everybody listening? Number one, you have to look at the person that you're speaking with, right?
B is not
important.
Okay. So what did you ask for this?
I have a question. So temporary, you can only
With
use
the
that
person
once.
you're having to, or observe what they're doing. What they do. Number three, think.
Whose audio keeps going on? Okay. Never mind. Okay, so what were you gonna say?
How does the temp work? Is that on just?
Or if you have an
the first use is that, is it like, does it disappear? Like it's not non-usable again. You'd have to reassign it.
Um, wait, sorry, can you say that one more time?
So you made a variable called temp. Is that just the name? Is it just like any other variable, or does putting it as temp mean that it'll like you have to reassign it if you want to use it later again? Sorry, I don't know if that makes sense, but
You mean redefine it?
yeah.
I will see you all.
Since you have it written as temp,
Wait, let me
the
stop
name is
there for a second. Sorry.
okay. So
Yeah, so keep going.
so since it's the variable is named temp, does that change anything? Does that change anything in the function of how that variable works? Like, does it mean that you can only use it once or something like that?
No, no,
or-
no, no. If you name it temp, we just named it temp. Like,
Oh, okay. Just want to make
yeah.
sure. I was wondering if maybe that serves a certain function.
So let me start screen sharing again. Sorry. Okay, so double temp is equal to this, right? And so now after we switch them, what can we do? We have to start our algorithm, right? So the nice thing is before we start this, it's always best to look at how we're gonna first plan out what we're gonna do. So the first case is if A is negative and B is positive, right? So let's say if A is negative, so if A is less than, f of A, my bad. If f of A is less than f of B, because remember, one of them, we already know from the while loop ensures that they're different signs. If f of A is less than f of B, that means that means f of A is negative, because f of B will have to be positive. Then we start our algorithm. So our algorithm in this case, let's use a for loop, right? So for int I is equal to 0, I is less than 60, and I plus plus, because when we bisect something, we divide it by 2, right? So in this case, we're dividing it by 2 60 times, which is approximately going to leave which is going to approximately divide an interval by 10 to the negative 18. So that will probably ensure us we have really good precision there, or really good accuracy there. What do we do in our algorithm? So our first step was we have to divide it in half, right? Right, guys? So let's create an integer called maybe, do we have an integer called n? No, we don't have an integer called n. So let's make an integer called n, such as n is equal to a plus b over 2. Not int, my bad, double. I for some reason use it as well. Right, do you guys agree with me? Let's create a double called n, such that n is equal to a plus b over 2. Afterwards, we check, is f of n.
You should put parentheses around a plus b.
Oh yeah, my bad, that's right. We have order of operations, right? So if f of n is greater than 0, what do we do? If n is greater than 0, what do we do?
Make that the new higher bound, make upper
Right?
bound.
You make it the new higher bound, but what is the current upper bound?
F of b.
B is the upper bound. So the current upper bound is b. So now b will equal n, right? But what happens if f of n is less than 0? Or maybe equal to 0? So else, what do you do in this case, else?
Would you ask them to I'm not too sure because I don't really remember this from algebra.
Okay. So let me start annotating again. So let me annotate in white this time. So let's say that, right? And this is our B. This is our A. We first cut in half. In this case, n is positive, so we replace the upper bound with n. But if n was negative, so let me clear this drawing. If n was negative, so this is our B and this is our A. If n is negative, what do we do? What do we replace with n?
The lower bound, A?
Yeah, we replace A with n. right? So now A is equal to n, right? So we just keep repeating this over and over again 60 times. So double n is equal to the average of A and B. So it is going to be the midpoint. Afterwards, we say if f of n is greater than 0, we replace b with n. And if f of n is equal to, if f of n is less than 0, we make a equal to n. Actually, let's define n outside, because if we define n in the for loop, n does not really exist anymore after the for loop. So let's make n equal to 0, and let's define n to be equal to 0 to 2. So this makes sense, right? So, but what
Wait,
happens?
aren't we trying to find for when f of n is equal to 0?
Not necessarily, because what happens if it's like if the root is some how can I say this? If the root is some irrational number, we'll never get to it, right? We'll never get to it exactly. But I mean, we could also have a statement in here, which is if f of n equals 0, we could maybe say something like exit the for loop. But let's just, I guess, leave it outside for now. I could probably make that an exercise for you. If n is equal to 0, we exit the for loop. But pretty much the way what we're doing here is we're making n so close, like we're making the bounds, we're making the segment of the graph that we're looking at so small that like the width will be 0.00000 something. So n will pretty much be almost exactly the same as a root. Do you sort of get it?
Yeah.
So but what happens if f of a is positive? So in this case, f of a is negative. But what happens if f of a instead is positive? So let me annotate this one. So if f of a is positive, in this case, this is a and this is b, and we cut it in half, what's going to happen? If the thing is, if f of n is greater than 0, we instead replace a with n, right? And if f of n is less than 0, we replace b with n. So instead, we just change the variable. So for example, let me so let's just copy and paste this for loop. So for int I is equal to 0, I is in 60, I plus plus, n gets a plus b over 2. If f of n is greater than 0, we replace a with n. A is now equal to n. These a's are upper bound now, or else we replace b with n, right? And now after we exit the for loop, the line segment, because we're doing this 60 times, and 2 to the 60 is approximately like 10 to the negative 18. I mean, to the negative 60. Now because n is now, the line segment is so small, n is practically equal to our roots, right? So all we do is we can say system.out.print approximately, my bad. And we just say plus n. All right, now let's run and see if this works, because the worst thing we could do is code a program and find out it has a ton of flaws in it. So let's first check if it has any compile errors. I'll answer lower bound. So in this case, x is equal to x cubed minus 3x plus 1. So what can a lower bound do? Can somebody tell me?
Lower bound means negative, right?
No, it could be anything. Just like lower bound just means, yeah, it's lower, and upper bound means it's higher than, like the x value is higher than the lower bound, right? So answer lower bound, any?
6.
Minus 10.
Minus 10, okay. And so negative 10 is obviously going to be negative, right? Because we have negative 1,000 plus 30 plus 1. That is going to be like negative 960 something.
Well, what is it? Negative 1,000 plus what?
Oh wait, never mind. Just it's negative. So we have to have an upper bound that is positive, right? So what is, you gotta say 10? Because 10 is obviously positive, right? So say 10, and what will it give us? The root is approximately equal to negative 1.879 something. Let's see if that's correct. On Wolfram alpha, and let's say x cubed minus 3x plus 1. Let's see what the root is. Root is going to be, okay, that's negative 1.8794. And so we have, oh, this is the wrong program. The root is probably equal to negative 1.87938. So, right? It works, right?
Nice.
You guys think this is cool? So it's a little bit complicated, but let's first look at the, if we got rid of all the flaws. So for example, if instead we had no sign change, let's see what would happen. And we put -5, error, no sign change. So it now asks us to re-answer the lower bound. Now let's do it, let's say 5 and 10. Okay, error, no sign change, enter the lower bound. So this while loop here is preventing the user from entering two A's and B's such that f of A and f of B are both have the same sign, right? And let's say if we had instead had the lower bound equal to 10 and the upper bound is equal to -10, we still get the same thing. The root is equal to -1.87, right? Because in this here, in this if statement, what we were doing is we were saying if B is less than A, so in this case, B was -10 and A is 10, we're just gonna swap them. So now B is now greater than A. So even if the user accidentally puts in a higher value for its upper bound, we just swap them and it's still the same exact thing, right? So let's do a new program, not new program, but like a new function. Does somebody want to give me like a function? A wacky function?
Sine of x.
Sine of x? Anything else?
Wacky enough.
Let's do cosine actually. Math.cosine of x. Remember, this is the math class. So math.cosine. We could use cosine for the math class. So what value is negative from the math class? I mean, not from the math class, in cosine. What value is negative or positive, any lower bound? 0, right? Because 0, cosine 0 is equal to 1.
Wait, did you ask for what was negative?
No, negative or positive.
Okay,
Anything
yeah,
that could be a lower bound. 0 is the lower bound, right? And what is an upper bound? By the way, keep in mind that Java does everything in radians. So that's going to be a little bit tough.
3.14.
And we get the root is approximately equal to 1.57. The root is actually pi over 2, right? And 1.57 is pretty much pi over 2. So this is also correct. Let's see actually how accurate this is equal to pi over 2. Let me check Wolfram alpha and let's say pi over 2. Let's see how accurate this got to pi over 2. 1.57079. 1.57079. Yeah, so this is actually very accurate, right? So do you guys like this program? It's a little bit hard. The hard part of this program, the main hard part is to think of the algorithm, think of how we're going to like code this thing, how we're going to plan it. But once we plan it, it's actually quite simple, right? It doesn't look that hard. All we did was we did this 60 times. So we have a for loop to execute what's inside, execute this thing 60 times. What we did is we took the midpoint as some value called n, and then we said if f of n is greater than 0, we replace b with n, or else a is equal to n. And we just do this 60 times, right? So all we're doing is we're just making the segment smaller, 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 until it gets so close to the root that it's pretty much almost exact, right? Does anybody have any questions with this? So yeah, congrats guys. I guess we just learned how to make like a TI-83 program. So
How many of these programs are in a TI-83 or 84?
Well, I think I would expect that the new TIs, I think they don't use this anymore. This is sort of like it's one of the, the reason why I would say that they don't really use this anymore is because you can't use this for all things. For example, let's say if we have x squared, you guys know what x squared looks like, right?
Yeah.
X squared is always positive except for that 1, 0. So in this case, if we use this for x squared, it will never work because we'll always get no sign change, right? So I don't think the the newer TIs, they don't use this anymore, pretty sure. I'm not sure, I don't quote me on that, but yeah, this is one of the most simple root finding things you can do. Another one you could do if you know calculus, you could do something called Newton's method. So if we have Newton's method, you don't need 2 points, you only need 1 point, and it could be any point in the graph, and it will try to find the root for you. But Newton's method requires calculus. So if you know calculus, you could try to code it. If you don't, then I guess you could wait until you learn calculus. So did everybody enjoy that one lesson?
Yeah, it was harder, but it was good.
Yeah, so I know the lab that we walked through together was really hard, but I'm gonna give you guys a challenge. Let me share the PowerPoint. Can everybody see this PowerPoint?
Yeah.
Yeah.
So I originally planned, I didn't know how long the lecture was gonna be. So I originally planned to do this as part of the lecture, but I had this Pokemon lab. You guys could do it as a challenge. So has anybody ever played Pokemon or has not played Pokemon? Raise your hand if you have played Pokemon at least. Okay. So do you guys know about the Safari Zone and like Fire Red, Leaf Green, or like old games? I'm pretty sure the newer games, the Safari Zone isn't actually like very like what it was before. So in the Safari Zone, what happens is that you run in the grass, you run in the tall grass, and if you encounter a Pokemon, you encounter Pokemon, except you can't battle it. You can only catch it or let it run away. So what you do is that you stand there with a rock or bait or a ball. And what you do is that you can either throw a rock, bait, or ball and try to catch it. So the way the rules that, at least in Generation 1 Pokemon, the rules that dictate whether Pokemon gets caught is that, first of all, every Pokemon has a different catch rate. The catch rate is in between 0 and 255. Next, whenever we throw a ball, in case of Safari Ball, whenever Safari Ball is thrown, a random number is generated in between 0 and 150. If the random number is below the Pokemon's catch rate, then the Pokemon is caught. Of course, if the catch rate is like 10, then you have a really low chance of catching the Pokemon. But we can always increase this. There's a little twist in this. So there's something called an escape number. So every time I do a move, if I throw a ball, I throw a rock, or I throw a bait, that counts as one move. And at the end of a move, an escape number is generated, a random number in between 0 and 255. If the escape number is greater than the Pokemon speed, then the Pokemon runs away and it flees. I cannot catch that Pokemon anymore. If I threw a rock, the catch rate doubles, but the escape rate also doubles. If I throw a bait, then the catch rate gets cut in half and the escape number gets cut in half. So pretty much, if I throw a rock, my catch rate doubles. I have 2 times the chance of catching this Pokemon, but it also has a 2 times higher chance of running away. If I throw a bait, then I have a 2 times harder chance of catching the Pokemon, but I have a 2 times higher chance of making the Pokemon stay. So I'm gonna leave this as a challenge. We're not gonna do it today. You could probably do it as homework. I could post it in the Google folder. Let's code a program that randomly generates a Pokemon speed with in between 100 and 125, and you can allow the user to do 3 options. Number 1 could be throw a Safari Ball. Number 2 could be throw a rock, and number 3 could be throw a bait. And pretty much, I just want the computer program to do the outcome. And you could keep doing it over and over again. You allow the user to keep trying to catch this Pokemon until either the Pokemon runs away or the Pokemon gets caught. So this is a very hard lab to do for you guys. It is a large step up from what we did, but this is sort of, I guess, you guys could code a simulation to catch a Pokemon. So
Is this Pokemon Go?
This is not Pokemon Go. This is like the original Pokemon games, like the old ones, like Pokemon Fire Red. This would be in the Safari Zone. Do you guys all know what the Safari Zone is? Like, can you raise your hand? Okay, I see many of you guys have not probably played the Safari Zone. But wait, let me search up a picture of the Safari Zone online. So I'm going to screen share this. So you guys know how normally you would battle Pokemon, right? In this case, you see this right-hand side. This right-hand side, instead of battling, you see where it says Safari Balls here, somewhere here. Yeah, this is called the Safari game. So normally we would battle them, like here. We would be battling Pokemon, but in this case, if we're in the Safari, we are only catching them. We can only throw a rock, bait, or a ball. So that's how the Safari works.
Does throwing a rock like trying to like knock them out or something?
I guess throwing a rock, injures them, but at the same time they get angry, and so they're more likely to run away. So I guess I'm not sure. Actually, I don't see the logic in the bait, because if you throw a bait, they're distracted and they're eating. So I think that it should be easier to catch them, but whatever. So as a challenge, I want you guys to code that. And so you don't have to do it. It's really hard. But if you need any help, feel free to email tutoring@xplained.org. The homework will be posted on the drive soon. Do you guys look at the drive? So if you look at, there's a couple programs in the drive. I'm going to add the roots finding program on the drive. I want you guys to sort of play with it. I'm going to add the other program, the factorial program on the drive as well. I just want you guys to sort of play with it, and you could alter it, do anything you want. You could maybe edit it, make it better. And I guess that's gonna be it. This is gonna be class. Oh, also tomorrow in the beginning of class, we are going to take a group photo. So if you guys could all please have your videos on in the beginning of class, that'd be great. And tomorrow we are going to be going over algorithms. So tomorrow we're gonna be, me and Kevin are both gonna be co-teaching this class. We're probably gonna split it, I think, half and half, and we're gonna go over algorithms. So I'll see you guys tomorrow. Thank you for coming. I hope you enjoyed this. If you have any questions, feel free to stay after class, and I'll be here to answer them.